So basically the thing is that we have a V in, this is error, this is the A, V out, F, this one. Okay, so if we are talking about the relation between the E and V out is E multiplied by A, that is V out. Okay, and E is simply V out upon A. Now, if V out increases, E increases. And if V out decreases, E increases. Okay.
Not understood, sir.
Sir,
Yeah.
in lectures, sir, the professor have some yanking the output way, right? That
Yeah. Basically, actually, I just tell you the two particular things. E is basically also equal to V in, that signal that is coming, and the signal that is coming. The subtraction of these two is the E. Okay. So
yes.
V in minus F time V out. Okay. So if V out increases, E is decreases, but it all depend on the depends on V. Okay. Depends on feedback factor F. Okay. So if we say that from this equation V out is increases, okay, and F value is in decim. So the effect of this one is negligible. Okay. So minor, or we can say the no effect on E. Like the feedback factor is 10 raised to power minus 4. Okay. V in is 5. V out is 2. So if error signal is 5 minus 2 into 10 raised to power minus 4, it is approximately equal to 5. If I increase the V out by 3, so when V out is equal to 2, when V out is equal to 3, E is equal to 5 minus 3 into 10 raised to power minus 4, is that is also approximately equal to 5. Okay, so we increase the V out, but E either decrease, or E constant, and these two will be defined on the value of feedback factor.
But the answers, the options marked as answers. How can we confirm those options? Like V out increase, E increase, and V out
if you
decrease,
if
E
you see
decrease.
in the diagram, if you see in the particularly professor tells, so every time the f value is very less, zero point 0.3. Okay, maybe some, it's maybe in the power of, if we say that there is a minor variation in the voltage, so our feedback value will be in 10 raised to power 4, 10 raised to power 5, or sometimes 10 raised to power 6 also. Okay,
But
so we
that's
can't
not
say that
how it is
the
mentioned.
v out, no, it is not mentioned, but professor, some in the statement professor tell that the feedback will be very less, and it is dependent on how much feedback we have to provide in the input part. Okay, whereas if you see in the, with this particularly diagram, with particularly this one, your a is the basically amplifier gain. Okay, and the value of the amplifier gain is minimum is 1, and it always greater than 1, so that means the value of a is always greater than 1. Okay, so we are considering this relation as compared to this one, we are not considering this one. That's why this question is given.
So, um, uh, in case V in is 0, then
If in case v in is 0, so what is the value of
yeah,
f? Two unknown parameter.
yeah. So F is, even though it's very small, but it will take E into negative, right?
Negative direction. But if it's 10 raised to power minus 6 or 10
And
raised to power
if it
minus
is,
5,
yeah, so
so
that's fine.
not
But then
exactly.
it will get multiplied by A, right? So that
Basically,
means negative
if we say
multiplied
that,
by A,
uh,
negative multiplied,
where
a small negative multiplied by A will be a large negative.
where we are asking
See,
the
if
relation
we
between the in and v out.
E
Okay,
and V
if
out,
you are talking about the
yeah,
small negative, multiply by a is the large negative. Okay, but it will be
yeah,
multiplied with the a now. We have to find out the relation between the e and v out, and e and v out relation will be defined by the two terms, two particularly equations. One is the e multiplied by a, that is v out. Second is v in multiplied by f time v out, that is also the error signal.
yeah, I got it now, sir. So we are specifically interested in the relation between
Amplifier,
E
amplifier.
and V out.
Yeah, e and v out.
So if E decreases, even though by a very marginal amount, there will be a large decrease in V out
V
because
out,
of
V
A,
out. Hmm.
and vice versa. So
Yes.
I think we mixed it up with with the process of determining whether it's a negative feedback or
Yes, yes,
positive
yes.
feedback.
Yeah.
Sir,
Yes.
uh, uh, the way I did,
Hmm.
yeah, here when we increase the V out,
Yeah.
uh, the left side
F
of
time V
the,
out. F time V out is increases.
yeah, yes,
You are using this way, no? You are using this way.
yeah.
Okay.
Let's if F is not so small,
Uh-huh.
then it will increase it at least a few
But
amounts.
it is dependent on the feedback, now. It is dependent on feedback. Somehow the feedback is not required. Then what? Somehow the feedback is, like, for example, I just tell you one example of why you are using the feedback. Okay, like I am taking one example that I have a AC
Yes.
in my house. Okay, this is my AC. Now I have to set a temperature of 27 degree.
Yes.
So what I do, I just set a temperature of 27 or 26 degree. Okay,
Yeah. Yes.
now what the AC do if I set the temperature of 27 degree? AC reduce the room temperature up to the 25 degree and it will be off. Like that means in this scenario no feedback is required. Okay, but along with that, the AC temperature sensing device will measure the room temperature continuously after 1 minute, after 2 minutes. That is up to you. So it will be measure the room temperature after several time period. Okay, and when the temperature is goes up to the 28 degree, my AC will be start working.
Yes.
Okay, so
Yeah.
if my output is particularly if my output is required output, that is a 27 degree, if my required output I am getting from here is more than the required output, my feedback will be go with the positive error signal, my power supply will be on, and in this scenario my particularly AC will be start working. But if my temperature is less than the required temperature, so in this scenario the feedback is no need of feedback is required. Why? Because I have to switch off. I have to switch off my particular device. So the feedback is not a compulsory condition that we have to require this feedback every time. That is on up to the requirement basis. Like possibly that if I don't require any feedback, so I can put the value of f is 0. Then E is simply V.
Yes.
Okay. So this particularly condition, second equation is only validate when you particularly identify and you just mention that feedback is always required, but it is not compulsory condition. Okay, we have to calculate this equation for calculating the gain of the system, but we can't say that feedback is every time required.
Yes.
Okay, so the value of f is not defined. Now we are talking about the amplifier. The amplifier is a basically system through this the process will be going on. Okay, like I have a supply of 220 volts. Okay, but my AC required the 1.5 ton, that means 1500 watt. So what I do, I have to amplify the signal, either the current, I have to amplify the current, I have to amplify the voltage, anything. Okay, so basically the this particularly amplifier is a device that is used to amplify the signal, input signal. Clear? Maybe if no amplification is required, I set the value of amplifier is 1. If the amplification is required, I set the value of A is greater than 1. So that means this particularly block is always used, but this block is only dependent then feedback is required or not. So that's why the my pretty sure condition is that E multiplied by A is V out is all the time. But this condition is only favorable when feedback is required. If no required, the value of f is 0, the E is simply V. So there is no dependent relation between the E and V out. So that's why we are not using this equation, we are using the first equation every time.
Yes.
Okay.
Yes, sir.
So this is the simple tricky question, like we say that. This is a simply tricky question. Question is easy, but approach is different.
Yes.
Any other doubts?
And sir, likewise in eighth question.
Question number 8. This one.
Yeah, yes, sir.
Okay. Now,
Yeah. Uh, yes, sir. So
what
here, yes.
is what is the V out is -2. Okay.
Hmm.
My gain is 10 raised to power 4.
Yeah, yes, sir.
So
I
what is
mean,
my
I'm yeah. I got the same answer.
Uh-huh.
I have the doubt on the question.
Okay.
So the question says the op amp is ideal,
Yeah.
but in this diagram, as per the diagram,
Mm.
some current, I mean, it is they are not of equal potential, right? Sir?
Uh, Actually, not this scenario. Okay. Like you are confusing with the feedback, na? That there is no feedback, so how we can get how we get the particularly output voltage.
Um, no, I mean, when we say ideal, the
Yeah, the
input,
ideal is that when no current will be going inside, there is no feedback in the operation amplifier. So how we get the output voltage?
yeah, yes.
Okay.
So,
So
yeah.
basically, the ideal, if we are talking about the particularly operation amplifier, okay, and we say that uh, like this is a scenario. Okay, we are saying the voltage at this point and voltage at this point will be same.
Yeah, correct.
Okay, but if there is no feedback and we are getting the AOD, that is the amplification.
Yes.
Okay, so with respect to AOD is nothing but V out upon V in. Okay, what why I am saying the ideal amplifier? That I am saying the ideal amplifier is the output input resistance. Normally, the input resistance of operation amplifier is what?
Zero. Uh,
Zero. Zero.
Output impedance, right? Sir?
Input impedance.
Input is, yeah, infinite.
Infinite. So my resistance value is infinite. And similarly for the output, it is zero.
Yes.
So the basically condition of the ideal operation amplifier is this one.
Hmm. Yeah.
The condition of virtual ground is only applicable when we are using the operation amplifier for as a negative. Okay. The virtual ground condition is only applicable when my operation amplifier will be working as a negative feedback circuit. But if it is not a negative feedback, if not a negative feedback, we can't say the virtual ground condition is valid. This virtual ground condition is not a condition of operation amplifier. It is a condition of negative feedback operation. Okay. So if now similarly way, if we are using the positive feedback, we are using the positive feedback, we can't say it is also work as a virtual ground. Can't say. Okay.
Yeah, yes. But in any case, the current, the
The
IS,
if feedback is not there, we can't say that it is a virtual ground concept will be effective. Only the case is considered that my input impedance is infinite and output impedance is zero. This is the meaning of the
yes.
ideal operation.
Yeah, okay.
Any other doubts?
Sir, could you solve this question? Question number 8.
This question,
Yes, sir.
where I am giving the value of AOD, I am giving the value of V naught. Can I calculate the V in value?
Yes, sir.
Easily, simple. Okay. So this value is at this point across this drop. So what is the value of V1? Vi value is, we are using the voltage divider biasing. So my V in is equal to V naught upon AOD. V naught is minus 2 upon AOD is 10 raised to the power 4. That means minus 2 into 10 raised to the power minus 4 volts. Okay. And I am not saying the V in, I am saying the V plus. V plus minus of V minus. Okay. That means the voltage difference these 2 points. Now, if the voltage drop across this point is this one, what is the voltage here? So Vi is related in what way with respect to this voltage? V plus, I think. Yeah, V plus. So Vi and V plus relation is, yes, apply the voltage divider biasing. So V plus is Vi into 1 into 10 raised to the power 3 upon the addition of these two resistance. 1 into 10 raised to the power 6 plus 1 into 10 raised to the power 3. Sorry, 2 into 10 raised to the power 6. So 2 into 10 raised to the power 6 plus 1 into 10 raised to the power 3. So I can now write on this V plus is equal to Vi into 1 into 10 raised to the power 3 divided by 2.001 into 10 raised to the power 6. Cancel out 10 raised to the power 3. Okay. And what is the value of Vi? V plus into 2.001 into 10 raised to the power 3. What is the value of V plus? 2 into 10 raised to the power minus 4. So minus 2 into 10 raised to the power minus 4 into 2.001 into 10 raised to the power 3. So minus 4.002 into 10 raised to the power minus 1 is equal to minus 0. Okay. Any doubts?
Sir, could you explain this V positive minus V negative thing?
Okay.
V by
Like
AOD.
we have this is my operation amplifier. Okay. This is the negative voltage. It is connected with the ground. Okay. This is positive volt Vi 1. This one, this is the V. Okay. So basically the voltage, if I draw the diagram, internal diagram, so it is a resistance. Okay. And at this point of these two resistance is basically called the V plus minus of V minus. Okay. This voltage is V minus because it is in negative terminal. This voltage is V plus, that is in positive terminal. So V plus minus of V minus, because inverting is as it is, non-inverting is with minus sign. Okay. multiply
Yes,
by
sir.
the gain AOD, that is V out. Okay. So what is the value of V plus minus of V minus is equal to V out upon AOD. V out is what? Minus 2 upon AOD is 10 raised to power. So it's become minus 2 into 10 raised to power minus 2. So V plus minus of V minus is equal to minus 2 into 10 raised to power minus 2. Now the voltage at the negative terminal, because it is connected to the ground, so it becomes 0. So V plus is equal to minus 2 into 10 raised to power minus 4. Now the voltage at this point or voltage at this point is minus 2 into 10 raised to power minus 4. We have to calculate this voltage. Okay. Now this voltage is across 1 kilo ohm resistor and this is 2 mega ohm resistor. So apply the voltage divider biasing. So V plus voltage is equal to this Vi is distributed in two parts. So Vi one is this resistance and one is this resistance. Now V plus is across this resistance. So what I do, Vi multiply by the same resistance upon addition of these two resistance, 2 into 10 raised to power 6 plus 1 into 10 raised to power. Okay, but we know easily know the we already know the V plus, so we can calculate Vi is equal to 2.001 into 10 raised to power 6 times V plus upon 1 into 10 raised to power. So Vi is minus 0. Okay.
Yes, sir. Clear.
Yes. Any other doubts?
Yes, sir. On question 2 and 3.
Of graded assignment.
Yes, sir. Credit assignment 1.
Question third and fourth. For the circuit shown below, the
2,
gain.
2 and 3. Sir, 2 and 3.
Okay. For the circuit shown below, the value of the output voltage V will be. Yes. Anyone who solve this question?
Question 3, right?
Question 2 and 3. This one. Yes. Anyone?
What's that?
Question number 2. How we solve this question number 2?
Yeah, 4 by 12 of V not equals 6Vx.
4 by 12.
12 of V naught, I mean
Yes.
V0
Yes.
equals
Okay.
6V.
Hmm. Basically, what we do here, like if this is the V naught voltage, okay, and parallelly we say that the voltage at this point, okay, and voltage at this point, both are same because it is a parallel. Okay, at this point and second point. This one. Okay, any doubt?
No, sir.
Okay. Now, if the voltage between these and ground is V naught, so what is the voltage at this point? I have a voltage. This is two resistance. We have the voltage V0. It is a 8K. It is a 4K. So what is the voltage at this point? Yes,
V naught 4 by 12.
V0 multiplied by 4 upon 12. Okay, that is V0 by 3. Okay, and similarly, 1 minus this voltage is equal to Vx. So what is the value of Vx? 1 minus V0 by 3 is equal to Vx. Okay,
Yes,
any
sir.
doubts? Now the voltage source is 6 Vx. So this Vx 6 Vx, I can say it is also the V0. Yes, any doubt?
No, sir.
Okay, why? Because this voltage, and this voltage all are same. It is in a parallel. Okay, so 6 Vx voltage, this one voltage is equal to the also equal to the V0 because it is connected this point and ground. V0 is also this point and ground, and this particularly is short. This particularly wire is short. So basically, voltage at this point and ground and voltage at this point and ground is same. Okay, so I can say 6 Vx is equal to V0. So 6 Vs equal to V0. So that means Vx value is V0 by 6. Okay. So if I put the value of Vx and in terms of V0 by 6, so V0 by 6 is equal to 1 minus V0 by 3. If I take into the left side, so V0 by 6 plus V0 by 3 is equal to 1. V0 by 6 plus V0 by 3 is V0 by 2, that is equal to 1. This implies V0 is equal to.
Sir,
Yeah.
why we use voltage divider across 4 kilo?
Across 4 kilo ohm, because I have to calculate the value of Vx. This one. Okay.
Yes, sir.
It is a voltage dependent voltage source. Na? So without calculating the value of Vx, we can't calculate the value of V0. So we have to first calculate the value of Vx. And the Vx value is voltage at this point minus voltage at this point. Okay. Voltage at this point is this voltage, 1 volt. And voltage at this point is the voltage at this point. So we have to calculate the voltage difference between these. Okay.
Yes, sir.
Clear? Any doubt?
Yes, sir.
Similarly, you can solve
Sir,
the third one also. Yes.
yeah, yes. Yeah.
Similarly, you can solve the third one also. Okay, just write third one.
Sir, in third diagram, the in place of 6, it should be uh,
Yeah, the voltage gain factor, that is 6 into 10 raised to power 5.
yes.
No, the for the circuit shown below, the if the term the voltage controlled source voltage source, the 6 into 10 raised to power 5, what is will be the approximate output voltage? Is there any change in the question or the question is same?
No, sir, the diagram isn't so accurate. It needs little modification in the
Okay,
basic.
okay, okay. Actually, I have changed the particular diagram, I think. The particular this diagram is similar.
Yes.
Mhm.
Sir, is this session streaming on YouTube?
Not streaming, but it is recorded.
Okay. Uh, I mean, if it's streamed, it will be easier to for the others to watch. Okay.
I will upload the session, but
Okay, yeah, sure.
why they are not joining?
I'm not sure. Some of them are working, I think.
Okay, so for that one, I have already created one poll now.
Yeah,
Tell me
correct.
the suitable time, but no one is responding for that also.
I actually voted the 6 to 8.
Yeah, you have voted, but no other one will be voted for that. Mm, 3 are voted and all are 6 to 8. Okay, no problem. I will upload this particularly videos on a YouTube. Okay. Any other doubts you can ask.
How to access this poll, sir? I I I I think I
It is
missed
available.
voting out
It is
in
available on
Gmail
your
itself.
G Space, G Cloud. I just check your analysis of the questions. Mm, highest 90 marks. So everyone missed the question number 5. Mm, there are two students 532 and 085. They are getting the one is the correct and one is the wrong. I don't know why. Mhm. And who is 496 available? 496. No. Two students are getting 153 and 158.
Yeah, I'm 153.
153 Gaurav
No, Muthukrishnan.
Ojamuthu Krishnan. And 158 008 085. Okay. Hmm. Now Week 2 videos are completed.
Yes, sir.
Yeah, two
Any
lectures.
doubts? Any doubts in week 2?
Oh, week two, yeah, complete. Sir, I have doubts in GA two.
GA2 graded assignment 2.
Yes.
Okay,
Ninth
but
question.
the deadline is not completed yet, na?
No, sir, it's over. It's yesterday.
Okay,
Completed.
okay,
Completed.
okay. Your week 2 deadline is completed?
Yes, sir. Yesterday was
Yes,
done.
sir.
Okay. Mm, yeah, you are asking about this one.
Yeah, yes, sir.
Yeah, tell me.
Yes, sir. So here, I think, no, sir, not this. Finding the R value.
R
The
is
other,
10K. 8 1.
yeah, yes, sir. So
Okay.
here, I think 4R is comes to be 10K. So R should be 2.5K.
Oh. Mm, mm, 2 volt, 3 volts. Mm. What is over RF? What is RF?
No, sir, I did it manually without just. I found the voltages at each node.
Okay. Is it better that can we calculate the value of RF?
Yeah, sure, sir.
So the value of RF is we go with this. There are two particularly part.
Is it 6.5 or something?
5
4R is 2.5K.
parallel with 4R plus 5. Okay, it is a grounded. So battery is that you have to calculate with the node. Two volts, 5K minus plus 1K, 3 volts, 5K, 5K, 4R and 1K. So yes, how you calculate it?
Um, me, sir.
Yes, yes.
Yes, sir. So the voltage at the minus, I mean, inverting terminal is 3.
Voltage at inverting terminal becomes 3. Yes.
So the current flowing from right to left through the 5K ohm
From
is 1 by 5 milliamps.
this one.
Yes, sir. If we draw from left to right, then it will be minus 1 by 5 milliamps.
Okay. So here you assume that 3 volt we are getting
Yeah, correct. Yes. So
because it
1 by
is a
5.
virtual ground concept. So we are
Yeah.
taking the voltage drop at this point is 0.
Correct.
Okay, so
Yes.
that means the both voltage are same. If this
Yeah.
is a 3 volts, so can I take it 3 minus 2 upon
2 by 5.
5K?
Yeah.
Okay,
So,
the
yeah.
current is
Yes.
going in this direction and the current is going in this direction. That means the current is leaving.
Yeah. Yes.
Okay, so can I add this one?
Yeah, yes, sir.
3, I say the Vx. So 3 minus Vx by 5. Okay,
Equals 0.
becomes 0.
Yes.
If we are talking at this point,
Yeah.
so Vx minus 3 by 5 plus Vx by 4
Or
uh,
eh,
plus
plus
current
Vx
coming,
minus
current going, and current going. So Vx minus
7.
this one is equal to Vx minus V naught V out upon 5.
Sir, here that is plus sign, right, sir? The Vx minus 3 by 5 plus
Why?
because
Wait a minute. Ah, yeah, okay. It is 3 minus not Vx minus 3 that becomes plus is equal to 0.
yeah, correct.
Okay, so I am getting the value of Vx from here.
Ah,
So 1 upon 5k is equal to 3 minus Vx upon 5k with minus sign. 5k cancel out. So minus 3 plus Vx is equal to 1. That means Vx is equal to 4.
yeah, yes.
Okay. If I put the value of Vx in this second equation,
Yeah, and V out
so
is 7, sir, as per the question.
okay, V out is given. V out is 7. So 4 minus 3 upon 5k plus 4 upon 4r plus 4 minus 7 upon
5.
5k becomes 0. So 1 upon 5k minus 3 upon 5k is equal to 4 upon 4r. Cancel out these two, so 1 upon r. So 1 upon r is equal to mhm,
Sir, the
2
minus
upon
1 by k, right?
2 upon 5k. That is r is equal to 2.5k. Mm, yeah, r value 4r is 10. R is 2.5.
Yes, 4R is 10.
Okay,
R is 2.
yeah, so I have to change the answer. No
And
problem,
sir,
I will change.
yes, sir. And likewise, the in the second question,
Mm,
second in the sense the next question.
ninth one.
Yeah, yes, sir. The
Okay,
um, yes, sir. Could you calculate once the V out?
the circuit should be shouldn't wait for 1 minute.
Yeah, yes, sir.
Hello. Yes, am I audible?
Yes, sir.
So first of all, tell me how you approach this one.
Yes, I first found the voltage at non-inverting terminal
Okay. Mm,
uh, by
voltage at
voltage
non-inverted
divider.
terminal. That means this point.
No, sir, the below one,
Okay,
non-inverting.
not non-inverting terminal. Yeah, this one.
Yes.
So two currents are
So,
flowing. One is this one and one is this one.
yes.
Okay. The value of the resistance is 2K and 2K.
Yes, sir. So the difference, half of the difference between these two voltages will be there.
So the total current I is equal to I1 plus I2.
Yes.
I1 is 2 upon 2K plus I2 is 1 upon 2K. That is 1 milliamp plus 0.5 milliamp. So the current I is 1.5 milliamp. Okay, now what? Or you can check. I just take the Vx.
Yes.
Okay, so the Vx upon 2, sorry, minus 2 upon 2
Yeah.
plus
X minus
Vx
1.
minus 1 upon
Right.
2
Yeah.
becomes
Equal.
0.
Yes.
Okay. So what is the voltage of Vx?
2Vx minus 3 equals 0.
Vx minus 1 plus Vx by 2 minus 1 becomes 0. So 3 Vx by 2 that becomes 2. Okay, and Vx is equal to 4 by 3. Oh, sorry, 1 by 2. It is equal to 1 by 2. So
Yeah. Yeah.
3 by 2. So Vx is equal to 1.
Yes.
1.5.
To reach
1.5 or 1?
one. I mean 0.5, right? No, half.
Why so? Vx and Vx is 3Vx by 2. 1 and minus 1 and minus 1, 1 by 2 is minus 3 by 2. So it becomes
Sir, here
this side.
the Vx, the first Vx also will have half.
Okay, Vx by 2. So that means Vx equal to 3 by 2.
Mm.
Okay. Now this voltage and this voltage both are same. Due to the virtual ground, negative feedback is applied. So I just said this voltage is Vy. Okay. So my Vy is also Vy. Now I apply the KVL. So if the current is coming in this way and current is going in this way, that means at this point the incoming current is equal to the outgoing current. So incoming current value is 0 minus Vy upon 5. That is equal to Vy minus V out upon 20. What is the value? Vy is 3 by 2. So I just cancel out this one. So it becomes 4. So minus Vy is equal to V by 4 minus V out by 4. Okay. I can take it this side. So 5 Vy by 4 is equal to minus V out by 4. These two are cancelled out. So V out is equal to 5 Vy, and value of Vy is 3 by 2, that means 1.5. So V out is 7.5. What I am writing here, 7.5 volt.
Yes. Okay. Yes. And sir, in the last question,
Hmm. The 10th one.
yes, yeah, here. Uh, so sir, here the source shouldn't it be connected to the positive terminal? I mean the non-inverting terminal.
For a negative feedback,
Yeah, yes, sir.
uh, can you break the loop?
Mm, yeah, yes, sir. So if we say plus and minus, if we assume the source is connected to non-inverting terminal.
Now, if I break the loop from here,
Yes.
okay. So this is behave as a loop.
Yes.
Okay. So when I break the loop, it becomes go higher, and when it is a positive, we are getting no, but not exactly at this point. We are getting the loop from the both side,
But
not
sir,
for a single
since
side.
we have voltage source at the top,
Yeah,
uh, increasing the VO will decrease the node voltage at that point, right? Automatically,
increase the VO.
will decrease the node voltage at the left side of phi. Here, there.
This one.
Yes.
Why so?
Because earlier the 5 volts is defined from some lower number of lower magnitude value, but since we are increasing it, then the 5 volts is not 5 volts, it is a little lower. uh, because when we calculate the answer for the next one, the minus 10,
Mhm.
we get the minus 10 when we have the plus and minus combination.
Wait a minute. Okay,
Yes, sir.
it is grounded. Now voltage at this point is what? If I say this is a V1 voltage and voltage at this point is V2. So what is the value of V1? 0 minus V1 upon, so this is the R1, R2 and R3. 0 minus V1 upon R1, that is equal to 5 volt.
V1 is 5 plus V naught, right?
Yeah. And V1 is equal to 5 plus V out. So this is the direction of current. I1. So the value of I1 is equal to, if I put the value, so minus 5 minus V out upon R1. Now V2 is 0, not exactly 0.
Half of views.
We have to use the direction of current. So this is the direction of current incoming. This is the direction of current incoming. Here we are getting the direction of this one, and here we are getting the direction of this one. So that means this behave as a loop. Okay.
Yes. V2 is half of V naught, right, sir?
V2 is
I mean, since R2 and R3 are same as per the diagram.
yes. Mm, I becomes 0. So in the scenario when I becomes 0, so the what is here? If R2 and R3 are equal, and this is the V out. So V2 is equal to V out by. Yes. But better that we are not solving this way. We can do one thing is here. What I can do in this. Wait. Question 10K 10K.
Sir, in this diagram or question, so in this case, as we have two kind of loops, uh, which should be chosen as the loop for checking the feedback.
Basically, the loop is that from where the current will be flowing. Okay. Like if I
Okay.
say that some current is coming from this side, the current is not going inside. So the is it possible the current will be flowing in this way?
Yeah, yes.
Okay. So if it is possible, so we behave as a this particularly as a loop. Otherwise, it is better to.
Because so far, I don't remember any question where we have seen these kind of loops where a loop
Yes.
contains
Yes.
source.
Okay. Give me 1 second. How I solve this one? And I do one thing here. What I can do. The 5 volt. We are using the resistor. Now we are using two resistors here. And this one short. So the value of these two resistors are 10K and 10K.
Yes, sir. Even the resistor given above is also 10K.
This is also 10K. So let's we assume by the terminal minus consider this is the plus, this is the minus.
Yes.
So what is the voltage at P plus? That is V0 plus 5 volt.
Yes.
V minus is also V0 plus 5 volt. So that means the voltage at this point is also, I can put it down. And so V plus is equal to V0 plus 5 volt and V minus is equal to V0 plus 5 volt. Now if this voltage is V0 plus 5 volt, so what will be the current from the positive terminal?
Which direction?
From this one, the current will be going in this direction because it is a grounded.
Yeah, correct. So it is 5 minus 5, right, sir?
So we can say I plus positive current is V plus upon 10K.
Yeah, yes.
Similarly, the current at I minus is equal to V minus upon 10K.
Yes.
Now, if I apply the nodal analysis at this point, so what we are getting?
So, sir, here V plus and V minus are uh, minus 5, right?
V plus and minus are minus 5. Why?
Because we calculated VO as minus 10.
V,
VO, V out as minus 10.
it is given in the
No,
question.
sir, it is the question,
You
the
have to
next.
calculate now.
Yeah, yes.
You have to calculate the VO. That is, so we don't know that what is the value of VO.
Yes, sir. It actually doesn't depend on whether the
I'm not
orientation is plus
considering.
minus
I'm
or
not
minus.
considering right now. I'm not considering the V naught. I'm just considering the V plus in terms of
Yeah,
VO.
yes.
Okay. Now apply the
Yes.
positive nodal analysis at this point. So what will be the nodal analysis? Just take the rule. Yeah. Okay. So we have seen that it is V minus upon 10K plus V minus upon V naught upon 10K, and both are 0. So 2 times of V minus upon 10K is equal to minus V naught upon 10K. So these two are cancelled out. So V minus is minus V naught divided by V. Okay. Any doubts?
No, sir.
Okay. Now V minus is minus V naught divided by 2. So if I put this value of V minus here, so I am getting minus V naught divided by 2 is equal to V naught plus 5 volt. Okay. Now it is V naught minus 3 V naught divided by 2 is equal to 5 volt. So V naught is equal to minus 10 by 3 volts.
Sir, do,
No.
do we have minus VO by 2 in V minus? Or is it plus VO by 2?
Okay. So yes. Hmm. Yes. So we are straight here. Deleting all this. Okay, so first thing is that we have to identify that which particularly inverting and non-inverting amplifier is that. Okay, that means the voltage is connected at what point.
Yes.
So initially, if I say the voltage at this point, if I consider that the VA point, so VA point is nothing but equal to
We
V out plus
5.
5 volt. Okay,
Yeah, yes.
so if I break the loop, increase the voltage. So if I increase the voltage, V out increases. That
Yeah.
means VA increases.
Yeah, yes.
If it is increases, so we are getting a positive sub signal or a negative signal. That is dependent on the terminal.
Correct.
Okay. So if I connect as a negative terminal, so we are getting the negative. Okay.
Yeah, yes.
So this is my first question is that I have to identify my supply will be connected at a inverting or non-inverting terminal. So it is a inverting terminal.
Sir, but if we take the other case also,
Yeah. The other take the voltage is zero, no? If we are taking this loop, so this loop, if this is a grounded, so we can say the voltage at this point is also zero
uh, it is
because
a
of
V
supply, not not
voltage.
not with respect to the V out. We are considering with the respect to the supply.
Uh,
Okay. At this point, we are not considering with respect to this one. We are considering with respect to this one.
uh, where, sir? The VB.
Here the ground voltage is grounded. This is
Yeah,
the
yes.
ground point. Okay. If it is a grounded, no supply is connected, so the current is zero. So that means this point is also grounded.
Uh, but sir, if that's only when if it isn't connected to the VO, right?
It is
It's
connected to
directly
the
going
ground.
to happen.
Yeah, it is connected to the ground. Now I am taking the effect of this particularly voltage. So if
Yeah.
I increase this voltage,
Yes.
what will be happen?
Increase.
Increase. Okay. But which voltage is higher? VO is higher or VO plus 5 is higher?
Okay.
Here, what
Um,
is the voltage? I am not taking a virtual ground concept right now. I am
yeah, yeah.
taking what is the voltage here?
Yeah, VO by 2.
VO by 2. Okay.
Yes.
And here, what is the voltage?
VO plus 5.
VO plus 5. Which voltage is higher?
VO plus 5.
VO plus 5. That means the effect at this voltage is higher as compared to this one.
Yeah, yes.
Okay. So that's why to provide a negative feedback, it is compulsory that this voltage will be reversed.
But sir, when we generally uh, take the feedback loop, it we actually have a voltage divider uh, necessarily, right? Always, so that it divides the output increase as a ratio, not as a constant thing.
Repeat, pardon your question. Repeat your
No,
question.
sir. If we take the upper loop as a feedback loop,
Mm-hmm.
then it is like a fixed one, right? I
There are
mean,
there are
the
two types of loop are there, as
hmm.
positive as well as a negative. But
Yeah,
we have
yes.
to identify first thing that where particularly we apply this particularly 5 volt effect either positive terminal or negative terminal to make it possibly in a negative feedback. Okay.
Yes.
So like for example, we have two signals. Okay. One signal is higher, one signal is lower. So the effect of the higher signal is good or effect of basically higher signal is high or lower signal is high.
Yeah, the higher.
Higher signal. So basically, if I consider this particularly terminal as a negative terminal, so it is better to maintain this particularly feedback as a negative feedback
Okay.
as compared to this one. I can put upper feedback as a positive, as well as I can put the lower feedback as a positive or negative. Okay, but the effect of upper feedback is higher as compared to feedback of lower feedback.
Yeah.
Okay. Second
Okay.
thing, the current flowing from this one is basically lesser as compared to current flowing from this one, because in the upper circuit there is no resistance.
Yeah, correct.
In the lower circuit there is the resistance, so the current will be follow only the path where resistance value is zero or minimum. So the current flow from this one, if I am taking the output voltage, if this is my output voltage, so maximum the current will be going from either upper or lower.
Yeah,
Upper
upper.
one, because resistance value is negligible.
Okay.
Okay, so the effect of this particularly for upper feedback is higher as compared to the effect of the lower feedback. So I just consider this as a feedback circuit. Okay, and for a negative biasing, it is only possible when this particular terminal is connected onto the non-inverting terminal. So the my first question is that I have to check where I connect the supply signal. So I have to connect the supply signal on a inverting terminal. This is the first question. Okay.
Yes. But sir, when we have VO as 0,
Yeah.
the feedback
You're,
signal should
you are also
also.
getting the from the feedback from this one because of this 5 volt.
Uh, so,
Okay. So
so at that time,
feedback is always maintained in this loop.
yes.
Clear?
Yeah, yes.
Little
Because
bit confusion.
before answering this question, I referred some internet source, and
Okay.
there I found that we use the voltage source in a, a feedback loop just to give a bias, and usually we have only the resistance divider as the negative feedback. That's why I had this
This
doubt.
time you have this particularly feedback as a negative feedback.
Yeah, yes.
If you are connecting this as a like for example as a feedback, okay, what is the terminal? Negative and positive.
Yeah, correct. Yes.
What is the voltage if V out is zero?
Uh, which point, sir? At which point?
This point.
VA?
V out is zero.
Yeah, yes, we have 0. So at that time, VA will be 5, and yeah,
Zero and
that.
5.
Yes.
Okay. Now
Yeah.
if I provide the zero, if this is the zero grounded and this is the particularly 5 volt, so it will behave as a non-inverting.
Yeah, yes.
Okay.
Okay.
Now how we justify this negative feedback?
Okay. So after this, so we will have 5 volts as the difference,
Mhm.
and okay. Okay. So then it will start pushing the
Actually,
load.
it is possible that if you are using the
Hmm.
upper terminal as a negative and lower as a positive, so your answer will be different.
Ah,
If you are considering this one is a positive and this one is the negative, the answer is different. If you are connecting this one is the negative, this one is the positive, the answer is different. But negative feedback, okay, if I break the loop, increase the voltage. Okay. If you increase the voltage, this voltage is increases. If this voltage increases, this voltage decreases. Either if it is connected in the negative, and if it is connected in the positive, the value will be increases. Okay. So
Yes.
if I consider this one as a negative and this one is positive. Now second scenario is that if this one is a positive, this one is a negative, then what?
Yeah. Now, doesn't the op amp tries to push the V out to -10?
It is increases, it is
Uh,
decreases. Okay.
yes.
But
Yes.
what is the effect of this one?
Yeah. It will try to push it up.
Push it up. Okay. The down will be lower and push will be higher. Why? Because we have getting here V out divided by 2 and here we are getting the V out plus 5. So downward is the lower and upward is the higher. So what
But
is
sir,
the overall resultant? What
anyhow,
is
the
the
output
resultant?
is just the amplification of the difference only, right?
Overall is the increasing, not decreasing.
I think overall, shouldn't it decrease?
Yeah, it will be like for example, it will be decrease in -2 and it will
Uh,
be increase at 5 volt. So what is the resultant? Is it Thevenin theorem or superposition theorem for both?
yeah, three.
If you remember the differential amplifier, professor tell that
Hmm,
it is a
yeah.
better way you can use the superposition theorem.
Hmm,
Okay, so what is the resultant? Resultant because of this one plus or resultant because of this one. So because of this positive terminal, the resultant is 5. Because of negative terminal, the resultant is -2. So what is the overall output? 5 plus of -2. That become plus increasing.
hmm,
Okay, so it is a
yeah.
positive or negative feedback? Positive feedback. Why? Because you increase the voltage and you are getting the voltage rise.
Okay.
Okay.
Yes.
If you are saying that it is a one possible condition is that if you are using this one is the minus and this one is the plus,
Hmm,
then you say that may be possible that if we are connected as a negative here and positive here, we are getting the lower voltage.
okay. Yeah.
Why? Because at this point the voltage will be subtracted, not added.
Yes.
Yeah.
Yes.
So this is my negative. This become positive. Now the negative voltage is, so I'm saying the VA is equal to V out. The direction of this one is positive, negative, 5. Okay, so V out plus 5 volt. Okay,
Yes, sir.
and if I say this is the VB, so VB is equal to VA. That is also same the V out plus 5 volt. Okay,
Yes. Okay.
now what is the current in this direction?
Um,
IA and IB.
yeah. So they are same. Right?
So IA is equal to VA divided by 10K, and IB is again VB divided by 10K. Okay.
Yes,
Now
sir.
I apply the nodal analysis at this point, VB. So what is the value? The current is coming from this side. Okay. And
Yeah, yes.
second, I assume the current is coming from this side.
Okay. Yeah. So minus VB by 10 plus.
Wait a minute, wait a minute. No, if
Ah,
both current are coming, the current is going in this direction, outgoing current, and there is not possible to point the current in this direction. So what I say, if the this is the direction of current, so the current will be going in this direction, and if it is the direction of current, the current will be going in this direction. Why? Because no current will be going in this direction.
yeah, yes.
Okay, so it's
Mm.
become VB minus 0 upon 10K. I am saying this is the direction of current.
Yeah.
Okay, and that
Yes.
particularly value is equal to this incoming current.
V out. V out minus VB by 10.
Okay, now these
Yeah.
two cancel out. So 2 VB is equal to V out. Okay,
Yes, sir.
now the value of VB, V out plus 5. So 2 V out plus 5 is equal to V out. So what we are getting, 2 times V out plus 10 is equal to V out, and V out is equal to minus 10 volts.
Yeah, yes.
Yeah,
This value doesn't depend on whether the op amp is in plus minus or minus plus configuration.
yeah, bilkul, absolutely.
Yes.
No, actually, this is not dependent on any of the value.
Yeah, correct. Only
Okay,
resistor
either
and
we are either we are getting the V or VB, both are
mm,
same. Okay, we are not talking about the positive and negative terminal. We are talking
mm,
about the V and VB. Either it become positive, it become negative, or all in all scenario, the value of V and VB both are same.
yes.
Okay, so it is not dependent on the particularly what is the in which one is the inverting and which one is the non inverting.
And sir, what's the reason we have this battery source in the loop and all?
That is only for the providing if you are providing the input voltage na. So in place of input voltage, what I do, I just provide the battery in a feedback path for a biasing purpose.
Okay, so and why we need bias here?
We need a bias because if we are not providing the biasing, so both terminals are connected with the ground. So if input voltage is it's ground for all the scenario, what we are getting the output.
Uh,
If you remember, if you starting the week 3, so in the professor are using like this circuit also. VB, remember?
yeah, yes.
Yeah. Okay, so we provide the biasing voltage also here. Okay, so in place of VB, I just put a VB here. This is the positive terminal, this is the negative terminal, and then extra V.
But
Okay.
this is the first time we are having bias on the output side, right? With respect to the VO.
Yeah, actually, after particularly submitted the assignment and your exam is really particular assignment is released, so I have a particularly this thing in my mind that you have not solved this type of questions.
Uh, yeah, sir. But yeah, we
But
learned in discussion.
yeah, but the particular thing is that either positive or negative. Okay, but
Yeah,
along
yes.
after with respect to this, there is no change in the voltage.
Correct. Yes.
What we are getting the output voltage that is the same.
Yeah, -10.
Okay.
Yes.
Any other doubts?
Sir, the assignment for week 3 isn't released, right?
It will be released either today or tomorrow.
Yeah.
Okay. And you are basically the you aware that your quiz one is the subjective paper, pen paper.
Yeah, yes, sir. Yes.
Okay, I just
Uh,
particularly announce in the group also
yeah, sure.
Google Space that your paper is subjective paper. Paper is a subjective paper.
Sir,
Yeah.
in, yeah, in lecture 1 of week 3,
Mhm.
the professor drew Gaussian surface around the